Okay. So now my camera's not working. That's okay. So I'm just going to talk. Can you all, wait, I'm going to share my screen. Can you all see my screen? Hold on, I'm going to share again.
Not
There
at
we
the
go.
moment.
Yeah.
Should be coming up. Hold on, I got to close this one.
Yeah, now it's visible.
Okay. Now, last session, hold on, I got to close this thing. Why is it doing that? I did updates to my computer and now it's like, okay, so last week we went we went through the process of working with subject matter experts and I played the role of a subject matter expert in maintenance planning, right? And this that actually I did work with a very high level person in aerospace, and his responsibility was this fleet of aircraft engines. The DSQs were, man, we had so many decision support questions because he had a lot on his mind. So he wasn't a data person. He was a I need to fix engines person. And I got a lot of data. And I got a lot of questions that I think can be answered by what's in the data. And I don't even know how to organize it. But this guy was brilliant. So when he helped develop, and some of the DSQs you all kind of guessed at were on his list. And then last week we just picked one. John picked one just at random because now we got to unpack the decision support questions. Now remember, if you're helping the SME develop these DSQs, they feel ownership of those things. That now it gets important to them, right? Because let me see if I have to admit anyone. Let me see hey, if someone's trying to get in and I don't see them, it's because I'm not paying attention. Just someone say, hey, someone's in the waiting room. Okay, so anyway, the DSQs we touched on were in that list, if I remember correctly. But he didn't have like 8 or 10. We had like 40. And then we had to kind of prioritize them, right? So we picked to as an example, we picked DSQ number 4 here. Where do the aircraft in my fleet operate? And that kind of leads me to these competency questions, which I think are more specific. Like what airports do the aircraft take off or land at? What is a flight? What are the phases of flight? Those might be wrong, but we started to go through a process, and I think it's a good process. But I'm going to show you a trick today that I think you're probably already doing it when you build an ontology. But what we want to get to is this column D, where from the DSQ, decision support question, we get the potential classes that are going to be in our ontology, right? So don't worry too much about the details. If you have a thought, let's inject it. But we're looking at the process. So if I get something it's not quite right, we'll work with it. All right. So let's focus on this DSQ. We're going to drill down a little bit, and the way we're going to do that is what I call the BFO low-hanging fruit. Okay. So what we're going to focus on, we're not going to talk about necessarily continuate fiat boundaries here or necessarily spatial regions. We're not going to get there yet. We're going to do the material entities, and that might include object aggregates like groups of things or, a team of people or a fleet of engines. We're going to talk about the material objects, sites like maintenance bays or rooms where they store parts, right? Or maybe the airspace above an airport, that would be a site, right? We're going to talk about these realizable entities a little bit, roles, functions, dispositions. We'll talk a little bit about those. And then we'll talk about processes or activities. And then we're going to bring in time. However we do the time, again, we're not going to drill down on like, Oh, it's a multi-second interval. We'll get to that later. We're doing low-hanging fruit. So physical objects, sites, dispositions, functions, roles, activities and processes, and temporal entities, if we want to call it that. So last week we started to fill this in, and there they are: material objects, realizable entities. That's those qualities, like the altitude of the airport. That would be something that goes in this kind of weird column. Processes and activities, sites and spatial regions, temporal entities, and then information. So I think we started to fill this in with John last week. So we started talking about material objects. And I think, oh, by the way, John apologized. He's at a meeting that I think we had the airport. Correct me if I'm wrong. The airport, the physical. Okay. And we had a great conversation last week. So by an airport, do you mean the site? Let's go to the site. Because we have two different things about the airport, right? We've got the airport site, and that's the ground upon which the air traffic tower sits, the runway, the maintenance bays, the hangars. So, but they all occupy what we call the airport, and we're going to put this in maybe like that. We're talking about the site of the airport. We might also want to include in here the airspace above the airport, right? That's also site, and they section it off with boundaries. You can't see them, you can't touch them, but they're right. We might have a maintenance bay inside the hangar, right? Okay, we got the physical airport. That's going to be things like towers, whatever. All right, so what other things do you want to include in this question? What other things do we need to do we and there's no right or wrong answers. Let's just see if you guys can come up with anything.
I mean, to answer where an aircraft is, presumably you have to have aircraft in your ontology,
Yep.
right?
Right. Now, right. Okay, that brings up a great point. A lot of these potential classes that we're filling in, they're going to repeat, right? So for an aircraft maintenance ontology, you're going to and just put them in there, even if they repeat, right? You're going to have your aircraft, right? You're going to have I think a runway, right? Runway will be we're talking about the physical runway. But yeah, aircraft, good. Keep going. Let's see how much of this we can fill in. You're on the right track though.
So I would also, I guess, want to include fleet, but it's not totally clear to me what sort of entity it is. Just because, like,
Awesome. See that object aggregate right there? That's where I'd put it.
okay.
So we're gonna put it right here.
Does the aggregation have to be physical in nature? As in, do they have
Okay,
to be like physically
good.
close to each other?
No, absolutely. Yeah. See, this is awesome. You've got a fleet of aircraft. It's kind of like set theory. That aircraft is in that set of fleet, or it's in that fleet, which is a set of aircraft that you care about. It might be in Shanghai, it might be in Seattle, but they're all part of that fleet. Love it. All right,
Wait, can you guys hear me all right? My audio might be.
Yeah.
Okay. I just wanted to say in relation to the object aggregate, I'm working on modeling the EU AI Data Act, and we model the AI systems as object aggregate, which obviously have no physical aggregation, but because they're systems that technically consist of other systems or are multi-parted systems, we just consider them object aggregate, just to say that they don't have to be like physical in nature.
Yeah, was that Alex? Was that you talking just now?
Yeah, it was.
Okay, so fascinating. No, I don't want to go down that rabbit hole because it's a whole nother conversation, but duly noted. That's a good point. All right, any other things? Let's go down the realizable entities too. Someone think of something. I said this last week. The altitude of the airports. That's something that's realized by it's a quality of the airport, I guess you would say. We'll just leave it in there. But well, just anything. Chime in. Whatever you guys think. We'll put it in here.
Well, flight itself is probably a takeoff,
Yep.
flight.
Right. Yeah, now watch this. They're taking off. Taking off, landing. They're landing at airports. Right. Oh, and this was one that you got to think axiomatically here. If there's a takeoff, what necessarily had to happen? This is the one. Remember, we talked about this. Startups are very stressful on the engines. So when I was talking to that SME, he's like, I care a lot about every time an engine starts up because it's a lot of strain on the engine. So if there was a takeoff, that means necessarily there was a startup. Good.
Maybe getting out of the scope of the question though, which is where do the aircraft in my fleet operate?
Yeah. Let's just leave it in there. Yep. Good point. You caught me going down a rabbit hole there.
I tend to spend more time than not going down the rabbit hole, so I'm trying to practice and ask out loud if this is the rabbit hole or if this is what we're supposed to be doing.
We'll leave it and we can cross it out if we actually I'm gonna do that. As a good note, Moskovitz is acting up in the thing here. Okay. I'm gonna cross it out on purpose to make the point. Resist rabbit holes. All right. Anything else?
I guess I don't know what sort of like how they keep time, but would you have to have something about like local time and then like the local time that things are happening at and
Yep.
Okay.
Yep. And let's just put any temporal entity that, and we'll work out the details later. But like the local time, the airport, whatever the airports, however they do that, the Greenwich Mean Time, they probably track that. One thing they do track, that freaking rabbit hole again, that is take off interval. There is a prescribed time how long it should take to take off. And then ascend, the aircraft should ascend at a certain rate. Let me see if my thing's working now. Man, my camera is not working. So much for my updates today. I'm just going to leave that in there. But there any other temporal entities that
I have sort of, if you do maintenance, you have sort of like a maintenance window, no? Oh, no, sorry, that's operate. Yeah.
Yeah, I was thinking that too. Data airport codes. Right? let's go down to this one. Airport codes, any other purely information entities that we care about for these. Oh, fleet ID,
Fleet
all
specific
kinds of
aircraft
these.
ID.
Yeah, tail numbers, aircraft ID.
Maybe engine ID if those are separate. I think you
Yeah,
mentioned that.
absolutely. Absolutely. That probably a serial number, right?
Rabbit hole, rabbit hole.
Yeah. 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 That's definitely a rabbit hole. We're gonna leave it on there anyway. We're trying to make the point here that, and even if you're, one of the things about being an experienced ontologist is you are definitely gonna have to keep people out of these rabbit holes. And unfortunately, I'm terrible at it because I want to ontologize everything. But and I think Alex made the point earlier, John. You're gonna see these classes, these things we're plugging in here, they're gonna repeat a lot. And at the end, your spreadsheet might have takeoff 35 listed in 35 different areas. Because that's what happens at airports. Planes take off. So we call those HFTs, high frequency terms. That means it's going to be a class in your ontology, right? So let's see. It's 11:27.
Oh.
Anything else? We can keep going.
Yeah, so I guess I'm not totally sure what is meant by where, if it's just the airport or not, but if it's more precise, then I guess you would want like geographical coordinates. And then I don't know if this would double up under altitude for both airports and aircraft, or you need a different altitude realizable entity, but just like where the plane is as well. So you get a three-dimensional precise number.
Wait, John, wait, back up. You said where the airport is?
Or sorry, I meant where the airplane is, where the aircraft is, in terms of like geographical coordinates.
Yeah, so that's data, right? That tells you the location. Now, when you say the location, you mean when it's stationary?
I meant when it's moving, but also I guess when it's stationary. I don't know if that's like if that's how they track it or what they do, but I guess.
Yeah, so
Yeah.
so now we're getting into the aircraft is pinging, right? It's sending out a signal from its GPS, so that definitely, so location is realizable because it changes. It's sending out a signal, and those signals register geo coordinates, which is information about the location. What you said, though, made me think about this. Those airports are in cities, right? So we're going to put we're going to put city as a site, right? The Buffalo airport is in Buffalo. The airport in Amsterdam is in Amsterdam. So we're going to have city and we're going to have city codes.
How would you handle that in the case of rural airports?
Yeah, so keep going, John. What do you mean? Like just
Yeah, suppose the airport doesn't have a city that it's that it's in, but it has like some broader uh political unit or like a county or a
yeah,
province
so
or whatever. And I
let's
mean
do
that's going to be
this.
different from country to country as well. I don't know.
Yep. City, county. Yeah, so in the Common Core ontologies, they have very general geopolitical entities that you can kind of say, hey, we'll call it a rustic airport. It's out in the country, and you can figure out, like, is there a code for that thing, for that site? Is that, is it we call it a county, a village? So you can work all that out. But yeah, good point. And in intelligence, you have these rustic airports that are being used for nefarious, drug smuggling or whatever. and they kind of try to hide them. So that becomes an issue, right? Yeah, city, county, ... You might have to create a new class for that. And then there will be data associated with that. It might just be a place name.
I was
Right?
about to ask, like, would you have to specify the difference between a city code and a area code or a, town code or whatever it might be that's there for the airport? Or could you just say like locational code?
Yeah, so I think there is I'm not looking at Common Core, but I'm guessing here you can create different classes for these things. If it's just a location code, and that a zip code is essentially a location code, right? A country code is a location code. So there's different ways you can skin that cat. Okay, let me um we're not going to do takeoff intervals. I'm going to put a line through that. Another rabbit hole. Local time. What's the is it Greenwich Mean Time? That is the general
Yeah, I think GMT is like the world time.
GMT is right. Okay.
UTC maybe.
I think it's safe to put timestamps in here because we put timestamps on everything. Takeoff, we landing, timestamp, maintenance activity, timestamp. So it's always safe to add some sort of timestamp, right? That's going to be one of those things that's going to repeat in a lot of your questions. Now, we probably have enough here, but this would get filled in, and then what would happen is we would then, let's say this is our ontology team, our dev team right here. We would do this for a while, then we would send it out to everybody, and then John would be like, "Oh, I'm going to put this in there," right? We would continue to develop this one DSQ and the potential classes. The point that was made earlier about John, well, wait, isn't that might be in another DSQ? Absolutely, right? There's going to be a ton of crossover. And then these are going to eventually make their way into that spreadsheet like this. Right? So they're going to make their way into a spreadsheet. We're just going to take all the potential classes. We're going to put them in one spreadsheet. Then we're going to create a column of what are they mapped to in the Common Core whatever your upper ontology schema is. You're gonna say that's a subclass of those things. So like if it's engine parts, right? Compressor, turbine section, bearings, lube system, fan. And then I always organize by column B because then it clumps everything together. Like all these maintenance activities, it starts to clump everything by BFO type words. So if there's a current like flight phases, that's something that happens, right? Approach, climb, cruise, descent, takeoff, taxi, all these things. Sites, facility location, maintenance sites, etc. Right? Maintenance activities, jet engine part, right? So again, you're gonna at the end, as you're doing these DSQs, you're curating them, you're collecting them in column A, and you just call it resource description framework label. That's your potential class. You're gonna then in column B, where's this gonna get mapped to? What's its parent class? Then you're gonna have a column C. You want to find a definite. Let me move this out of the way. Right? You're gonna try to define everything. Now, some people make a rule. This is a rule that people in medicine or very precise sciences, they do not add any class to the actual OWL file until they have a definition for it. The thinking there is if I can't define this thing, like if I don't know what I mean by inlet section, which is a jet engine, a part of the jet engine. If I don't have a definition for it, I can't explain it. It could be a realizable entity, it could be a process, it could be a material object. If I can't get a definition for it, it doesn't go in the ontology yet because it's just going to confuse people. Well, what do you mean by that? Why are you putting that in there? What? Be specific. So if you have that rule, that's good. I know people at UB I know one medical doctor in particular, he will research every potential class in column A. Now his ontologies aren't going to be this big because he's going to define like a disease or a variant of a disease, and he's going to get very specific about the disease process and the things that it, the material entities that it affects. And he will not, so his ontologies are going to be a little bit smaller, but he's very precise. So the way we want to get our definitions is turn to the SME and say, hey, you like our list, right? And we're showing this to this subject matter expert. Now, remember, this person, once we build out, let's say we have 100 classes in here, potential classes. We keep sending it to him saying, hey, does this look right? Are we missing anything? And once we get it down to like, we feel pretty confident in this, one of the questions we're going to have for that SME is, do you have technical manuals where we can define these things? You can use the good old Oxford English Dictionary. If they're real general things, like what is an aircraft? You could probably find that in the Oxford English Dictionary. And then you put the source in here. You want an authoritative source. So in aerospace, I wanted to use their technical manuals because and I don't remember who brought this up last time. Like, oh no, it was Jeremy. I don't know if we scared him off, but he had a good question. Like, what if you have a conflicting, like two different people want to define it differently? I don't get into that. I'll put alternate definitions in. You can do that in the ontology creator. You can say, this is our primary definition. It comes right out of your technical manual. But then you've got these other people that want to define this thing differently. You could put alternate definitions in there. So this spreadsheet is going to become the thing that we're going to turn into an OWL file or a turtle file, the machine readable Protégé thing, right? Now, you remember the reason I brought this table in here, I'm going to tell you the story of this. This was, I met this woman at a big conference in the ontology of maintenance. And I think they took like 800,000 maintenance work orders. And in the maintenance work orders, they ran them through and they extracted the most commonly used maintenance terms. And they're in this column right here, right? And then I think they added some, like under repair, they had some subclasses under there. And then they found that with this taxonomy of maintenance activities and sub-activities, you could do a lot with that. And then what I saw was in their definitions, they used international standards to define these things. Right? So these are right out of the ISO things. What do you mean by adjust? Bringing any out of tolerance condition into tolerance. We can make that better. Right? So what does it mean to refit something? Right? What does it mean to test it? Right? So my point is, if they don't hand you a technical dictionary, ask for it. If they don't have it, this is one of the fun parts of our job. Getting to this point is fun, but then helping them develop. I've seen definitions that go on for paragraphs. And you read the definition, you're like, what the hell are they talking about? Like, I think they know what this means, but no one else is going to know what this means. And I've taken their lexicons, gotten these paragraph long definitions, because it's just people rambling about They're just talking about, well, this is what this means and yada, yada. That's not a definition. Definition should be concise, two-part Aristotelian genus species definition like you would find in the dictionary. Now, all that paragraph, that can go in as a comment or an elucidation. You can absolutely put that in there, but that's not your definition. That's just wisdom of the expert, and you can just put it in as a comment or something. Sonny, go ahead. You were going to say something?
Yeah, this is really nice because there is these ISO standards, and there must be more standards. There's so much work going in there, and ISO standards have a bit of a bad name. But for me,
Yeah.
I also know that, for example, AI governance standards, they're pretty reasonable, and it means that you need to operationalize these things if it's a management standard. And by way of, ontology, you can actually start modeling out like, hey, this is how we're going to look at operationalizing a standard.
And 100%. And what happens, Sonny, is that has a tempering effect on the whole group. Let me explain this, and you guys tell me what you think. Let's say you say, okay, what's the definition of lubrication or inspection? And they're like, I don't know. You put grease on. No, what's the official sanction? What's the officially authorized definition for that thing? And a lot of times you'll get, they'll look at you like, well, we just know what it means. And then you find out they have a dictionary and it's in there. Or they don't, and you go to the international standard and you find it in there. Now you pull that into the spreadsheet. The next meeting, you bring that up. All the experts are looking at it. They're like, oh, that's what we mean by that. And they're like, well, we don't mean that. Okay, well, that's fine, but this is what the international standard says. You're telling me now that you have a different definition for this thing. Now they're all looking at each other like, oh, we better have something better than this. And that's fine. Again, we can have the ISO definition. We can have some specialized definition in there, but we're going to, and this goes back to that question that Jeremy had. It's not your job. Well, yeah, no, it is kind of your job. It's to coach them through these decisions, right? And if they can't decide, say, hey, let's put in both definitions. Let's put in the ISO definition. Let's put in your definition, that kind of your localized, specialized definition. And that's going to go. My Protégé is closed. We'll talk about that next time. Okay. Now, what I want to do, we're going to come back to this discussion next time when we actually start building this in Protégé or whatever we're going to do. I wanted to show you all. We've done enough of this. We could trust me, we can fill this in way more. But I think everyone gets the point of what we're doing here. But what I want to show you, can you all see my PowerPoint presentation?
Yep.
Yeah.
Okay. What I want to show you is, as an ontologist, this is one of the best tricks in your bag of tricks. It's you think axiomatically. That is to say, if you get a simple, and I think John made this point, flight is going to be in like all your DSQs because that's what happens at airports. There's a flight and it takes off. You have to think, write this down or jot it down in your brain. If you have that one class, that's going to explode into axioms. And what I mean by axiom, I mean what it says in the dictionary. It's self-evident. If there's a flight, there are self-evident things you can say about that flight. Who wants to take a shot at the first one? And this goes right back to BFO, the structure of BFO. If there's a flight process, that means what necessarily? 3, 2, 1, there's a participant.
Yeah.
right? So if there's a flight, that means there's some material object. It might be a bird, it might be a cannonball, it might be an aircraft, but there is a participant. Now, does anyone want to take a stab at another axiom, an axiomatic truth of either one of these, either the flight or the material object?
Well, I have sort of conundrum that of sort of a challenge like, okay, an airplane has flight has participant airplane,
Yep.
but at the same time that airplane has an engine part, but I want to see then the airplane as airplane and not as aggregate of parts. How do I manage
Okay.
that? I don't know if this is the right question at the right moment. But
right. So if you have flight, there's certain axiomatic things you can say about the flight. One is that it has a material object, could be a bird. In that case, the bird does not have an engine, but you could say its heart or its brain or whatever, but we're not going to do that. It's not axiomatic. What we're going to say, and it's just going to sound silly for a little while, but you're going to see how it takes off. Necessarily, that material object has a capability. It's capable of flight. That's one of those realizable entities. And that flight capability necessarily means it has propulsion capability, lift capability, and attitude control. It has to, in order to have a flight capability, it has to have these other capabilities. Even when it's not doing it, even if it's not in flight, that aircraft, that bird, it has all three of those capabilities that make the flight capability. And that is realized by the actual flight. In other words, you can't point to the bird's flight capability, but you can point to the flight and say, oh, that bird or that aircraft has a flight capability. It has propulsion, lift, and altitude.
wow.
It's not only true about the world, it's true of how we think about things. Now, we can keep going. If there's a flight, it necessarily has parts. To take flight, you're going to accelerate, you're going to take off, you're going to ascend. Maybe you'll cruise, even if it's just for a second. Then you're going to descend and you're going to land. Right? Now, what's true of these things? What's axiomatically true of these classes, these processes up here? Anyone want to take a guess? Think of temporality.
They have a starting time now and an end time.
Yep. Yeah, you can't land before you accelerate. So what we say is these things are related to each other. One precedes the other. You can go in either direction. You could say the acceleration precedes the takeoff, or you could say the takeoff, I don't know what the inverse of precedes would be, but it would be, you can invert this.
Yeah.
You can say they overlap. You can say the ascent and the cruise overlap. You could put that in there. But there are relationships that we can use to talk about, to represent the way these things are related to each other. We could do a better job of that. Another thing about the flight that as an ontologist, you're coming into this meeting, I don't care if it's a flight, I don't care if it's an airport, I don't care if it's a human being that's performing surgery. These are the types of questions that should be running in your mind, these axiomatic questions, right? Flights don't just happen, they happen in time. They don't just happen in time, they happen in space, always. And that site occupies a three-dimensional spatial region. So I would say, and I'm probably missing some things on here. My point to you all is when you're building an ontology and you have something as simple as, oh, we've got this class flight. You can start to say, in your mind, you'll unpack that. You'll say it's got an aircraft. The aircraft has capabilities that realize the flight. We know that there's parts to a flight. We know that there's temporal reasoning to be done there. And we know that it happens in space and time.
Really nice.
Right? So if you get this trick down, And I'm going to tell you right now, I've been to modeling with really smart people modeling things. You use this technique right here, and you're gonna look like a ninja. You're gonna look like a black belt level modeler because they don't think of the connections like this. And guess what? The computer can use this logic for queries, right? And so let's say your material object is, we can do this with anything. Let's say, actually, we did do it right here. We kind of did do it in this format, right? So if there's, where do my aircraft fleet operate? You're asking axiomatic questions about that. You go down rabbit holes like takeoff intervals and engine startups, but generally you could build an axiomatic graph of an airport right here. So if you listen to anything I say, this is probably the most important thing right here. Is think what are the axioms of the, it's just a necessary, you think about this flight, this notion of a flight. You could almost write your definition from this. You could say a flight is a process that has a material entity participant, bird, airplane, whatever, that has certain capabilities, and it includes these processes that happen in space and time. This is your definition of flight right here.
Wow. Impressive. Really impressive, that breakdown. And a question, Bill.
Yeah, go ahead.
So you really sort of make this a bit more abstract. You say like, okay, I know I am modeling for airplanes and maintenance, but let's just think of flight as well, not as abstract, but as correct as possible. And in a way, like you said, it could be a bird, it could be a plane, and it's way better to model it in a more general way.
Yep.
Do you have anything to tip on that, or teach us a bit more?
So,
like, because it sounds really sensible, but I would be like rabbit holing immediately to flight, plane, jet engine, you know?
Yeah.
Sort of like...
Yeah. So the way to keep from rabbit holing, Sam, I see your hand up. I'll get to you. Is again, who's writing the check? They get the biggest say in this. And let's say we go from flight to material object, and Sane raises his hand and says, all right, look, let's cut to the chase. We're talking about my engines in my aircraft. Now we have aircraft has part engine. Maybe it's got 8 engines like the bomber. Now we've got engine. We've got aircraft has part engine. Engine has part, the 6, 7 major parts of an engine. And those each have functions. Our capabilities over here are attached to the functions. So what's the function of a combustor? So immediately we've gone from flight to material object to decomposing the plane into its pieces and parts, talking about the functions, and boom, now we're already attaching data to each of these things. So this goes very quickly. Very quickly.
Yeah. So can a material object have a material part without being object aggregate, no?
Yeah. Oh.
Sure.
Sam, I promise I'm going to get to you. Sonny, that's like the biggest, like, isn't a car an object aggregate? It's a system of systems, your car that you drive. Well, you could treat it that way. But what we've come up with, an object aggregate is like all the pens in your cup that you have on your desk, or all the people in the meeting. That's an object aggregate. Yeah. All the engines in your fleet. Don't start saying that your vehicle, your car, is an object aggregate. It's got an engine, it's got a drive train, it's got brakes. Just call it an object and say it has parts.
Yeah.
Car has part engine. An object aggregate, you'll say, has member, right? So your organization is an object aggregate. It doesn't just have parts. It does. They're called members, right? Sam, you have your hand up. Go ahead.
So I missed most of the class, but 'cause I had something else come up. But so I'm looking at the design pattern on here. So you can use this design pattern, and you could eliminate propulsion capability, right? In the case of a
Yeah.
glider, you could say, "Hey, there is nothing. There is no propulsion on a glider. It's
Yeah.
externally. It relies on
Yes.
external power, so you don't have to include that."
So Sam just brought up a good point. As I was making this, I was trying to think of an example, and I think glider may have come into my head and went out very quickly. Um, but then that would not be an axiomatic statement that it has a propulsion capability. Because with a glider, the propulsion capability is external. Yes.
Do we want
Um,
to say that gliding is the same as flying? I
yeah,
guess. Yeah.
this is where, okay, so now this is all leading to a good point. When this conversation starts, when you're like, well, I have this point of contention. I don't think I don't think gliders are in this definition of flight. Talk for like 10 minutes about it, put a pin in it, and then get all the nerdy ontologists into another room and hash it out. Because the SMEs, they want to hear a little bit of what you're, and they'll be like, okay, these guys, they're really thinking about this, but they don't want to hear the rabbit hole that you're about to go down. And it's a good rabbit hole. You absolutely have to do it because you're right. Gliders don't have a propulsion capability. Actually, I don't think they do have a lift capability because they can go up and down and you can control the attitude. So they do have that, but good catch, Sam.
But
I mean,
at
I don't
this,
want to end up down another rabbit hole, but flight doesn't have to land unless it wants to fly again, right? Like flight is just the act of being in the air. You don't need to take off or land
Yeah, so I
to be
thought about
flying.
this. Like, yeah, so does a star, I don't think we call that a flight. I think we call that an orbit because it's not taking off or landing, it's just going, right? And then your point, Alex, about does it have to land? Yeah, I think
Landing
you got
only
I
allows
think
it to take flight again. It has nothing to do with the flight itself, I don't think.
yeah, so I think what we're talking about is then we have to go back here in our material object. We're talking about a jet aircraft, and even that doesn't have to land. It could get blown up in the air.
Yeah.
Yeah. Good
So
point.
I get the point. The only reason I even bring that up is I feel like, and I don't want to keep having the same rabbit hole conversation, but there's this like constant awning of there's other ways I can think about this and model this and view this, and I can make it more complex or I can make it more simple. And it's very difficult as somebody who doesn't really know anything about the space besides what we're learning, where to draw those parameters.
So you're not if you're a philosopher, you're not going to like this answer. It's what they support, how much funding they have, and if it
Yeah.
answers their maintenance questions, that's as good as it gets.
Yeah. All right. Makes sense. Just do what you can and need to for the job.
If Moskowitz is sitting in the meeting, he's like, hey, it doesn't have to land. It's a great point, and all the ontologists are gonna be like, oh yeah, yeah. But again, have that conversation for like 10 minutes so that they know we're not messing around. But then if they say, listen, our shit always lands, okay? Just leave it in there. That's a great point, though.
Yeah,
I think
I really asked it because of in reusability, right? So I understand.
Yeah.
So right, the customer wants it to do it, right? The whatever the customer is, aeronautics, they for their purposes, everything pretty much lands, unless if it's some extreme case. But you go on
Yeah.
to do something else to model something in space or orbit or like something that stays up for a very long time. Landing just seems like there's
Yeah.
seems like it'd be hard to I guess you could reuse it. You'd have to use this as a starting point, but then you'd have to remodel some of the things.
Yeah. So, I mean, you start running this material object and you start filling that in with like, and that's what I was doing. Like, okay, there's a meteor and it's accelerating or it didn't take off. Well, maybe it took off. What does that even mean with a meteor? It doesn't really have attitude control. It's just going and it's based on gravity, right? So that's not really a flight. That's an orbit, or is that, well, that's kind of a flight. So in other words, as you run through the different types of material objects you're going to plug in here, a cannonball, a missile, you're going to start to uncover, I think, problems and rabbit holes with my model here. But yeah, this is what we do for about, again, 10 minutes, maybe go 15, but don't go so far down the rabbit hole that the SMEs are like, okay, these guys are burning, these guys are expensive, and everything we have lands. If it doesn't, we have a problem.
Yeah. Bill, you showed earlier that these flights in reality have a very structured thing like takeoff, first plateau, first ascent, second ascent, cruise, first descent, second descent, and land. So and it's also name spacing thing. Now, if you're making this for airplanes or mechanical flight, let's put it that way, then 80% of the time, yeah.
And okay, now listen, what time is it? Oh, we're a little bit over. So every one of these phases of aircraft flight, we could make a defined class. We could make a defined class, aircraft flight, right? We could do that. Every one of these phases has data associated with it. So it should take about 6 minutes from the time it starts its climb to it's up here and it's gonna cruise. That should take about 6 to 8 minutes. This is all part of the flight plan. Lots of data hiding in this picture right here. And of course, the altitude, the cruising, it's going to change altitude up and down. But there are prescriptions for that too. Maybe it goes around a storm. And then the descent should take so long, right? But again, all right. So all great questions, all great. I was so happy with this, and now I'm not so happy with this graph. But it made the point. Made the point.
That is a great graph.
Uh,
All right, we'll pick it up here next week. We're gonna start building it in, I guess, Protégé, whatever John wants to do. John was busy this week, but I'll send this over to John, and then we'll pick it up from here. Keep these questions. These are the questions you need to be asking. So good work.
All right. Thanks a lot. Have a good one, guys.
Okay, everyone. See you.
Fantastic, Bill. Thank you a lot.
Yep. Thank
Thank you.
Bill,
Yeah,
one
go
more
ahead,
question.
Sonny.
You had this really nice presentation about document ontology.
Yes.
Could I maybe ping you a bit on that later? Would that be a possibility?
Yeah, so here, hold on, let me cancel that. Do we have the chat? Hold on. Here's the chat. Let me go like this. I'm putting this in the chat. Lee Mandrake at Hubert.org. Just shoot me an email and tell me what you need, and I'll send it to you.
Got it. Thank you. Great.
Okay.
Yeah, I was really impressed by it, and I think it's necessary in so many places. I'm like, this is really a big thing. Let's put it that way.
Yeah, so I'm teaching a class, I think next year. We're putting the class together right now. And the title of the class is for the online degree at UB. The title of the class is The Ontology of Law. But it's really about the ontology of any sort of document that prescribes behaviors. It could be a plan, it could be a legal document, it could be a regulation, an international standard, but we're going to focus on law. But a lot of what we're going to say about the law is going to apply to other fields too. Yeah. So, and this is definitely I'm finding out the more I research it, this is a huge topic. The discipline digital law is a real thing. And then all the ethical questions come in, like, do we really want algorithms making legal decisions, right? Do
Yeah.
we want AI making legal decisions, and what does that even mean? Right? So
Yeah.
fascinating.
Absolutely. Thanks.
All right, man. We'll talk soon. Bye.
Later. Bye, Bill.
Bye.